So welcome back to differential calculus class. So we are still on rules of differentiation. So in this class I will be teaching you how to find the derivative of implicit function, applying implicit function over. So this is an example of an implicit function where we have a x raised to the power n plus b y raised to the power n plus c equals 0. Here a, b, and c here, they are constant. Okay, they are constant, and with n and m, they have powers of x and n, that they are real numbers. Anyway, real numbers. Okay, now, so before we start applying this rule, let's first differentiate between implicit function and explicit function. So the functions we have been dealing with in our previous classes, they are explicit functions. The explicit function in the sense that we have the dependent variable on one side and the independent variable on the other side. For example, if you write the function like this, y equals 2x squared plus 5, something like that. So you can see we have the dependent variable on one side separated entirely from the independent variable on the other side. Okay, they are not on the same side. But what this is an explicit function. Explicit function. What of the whereby we have both the dependent variable y and x, the independent variable on the same side. For example, let's say we have 2x squared plus 5y equals 0. You can see we have both the dependent variable y and the independent variable x on the same side. So in other words, this function is called implicit function. So when we are given an implicit function and we are asked to find the derivative of the function, how do we do that? So just pay attention to this class. Now, as we are given this and we are asked to find the y dx. So we have to find the y dx, that's the derivative. How do you do that? So it's very simple. So the rule says that given this, we have this. That is, we have a x raised to the power n plus b y raised to the power n plus c equals 0. So what we are going to do is that we are going to differentiate each of the components with respect to x. Okay. Now, for example, we are going to have dx n plus dy n plus c equals the 0. This respect to x and this also respect to x. So we can now split this. So we distribute the derivative sign. So we have d a x raised to the power n with respect to dx. Then we have plus d. We have b y raised to the power n over dx. But there's a plus here because it is this component that carries y. So we are going to do this, we say multiply by the derivative sign, the y dx. So we not put it here because this one carries x. We multiply the y dx by the component that carries y. You can see here. If we have more than one component that carries y, we are going to do it for each of these components. So then equal to d0 dx. Okay. So this is what we are going to solve. Then we make our dy dx the subject formula. So let's take a look at an example of this in order to make it clear. So let's assume we are given a function like this, that is we are given 3x raised to the power 4 minus 7y raised to the power 5. Then we have minus 86 is equal to 0. Yes, something is missing here. Sorry, there's one thing is missing here. Okay, that thing that is missing here is that I just forgot to put dc over dx. Then we have d0 over d. Please take note of that. So I just saw it, it's a mistake, the number side. So plus this, because we are to distribute the sign of derivative here. So I omitted this c, so I'll put it back. Okay, now yes, I have this. So if you are to find the derivative, that is find dy dx. If you are to find dy dx, so we apply this one. So are we going to apply the rule? So let's do it. So we are going to solution. So we have the 3x raised to the power 4 plus 7 y raised to the power 5 minus 86. Then we have d 0. We have the x. This also the x. So we distribute it now. So when we distribute, we have the 3x raised to the power 4. Then the x. Then we have minus the 7y raised to the power 5 over dx. So don't forget this one carries 2y. So we are going to multiply by dy dx. Then next one is minus 86. We have d 86 over dx. Then we have d0 over dx. So then when we differentiate it with respect to x, we multiply the power by the coefficient. We have 12x raised to the power 3. We are done with this. We move to the second one. We differentiate this one. 5 times 7, that is 35. Y raised to the power 4. Then don't forget we have dy dx. Then we have minus division of a constant. If this is a constant, division of a constant is 0. Okay, that one will go away. So we don't necessarily need to put it there because 0. Then we have equal sign. Division of 0. 0 is also a constant, it's equal to 0. Then we collect the like terms. So we now have 12 x raised to the power 3 equals 35. We take this to this side, we have 35 y raised to the power 4 dy dx. Then what do? We now have our dy dx. You divide both sides by 35 y raised to the power 4. So then we have 12 x raised to the power 3 divided by 35 y raised to the power 4. So this is our final answer. So can you also try this? Try this. So we have an explicit function on this. So I have to find dy dx. If we have 2x squared plus 5y squared plus 5y squared equals 0. Drop your answer in the comment section.